Okay, this is another projectile motion problem with a person. The end of a seesaw being projected in the air. She's leaving at 15 meters per second at an angle of 70 degrees. So once again, we often need to get at the very start of a problem the horizontal velocity, which is going to be the range that she would travel in, but that is only if we're interested in finding the range. And the vertical velocity, which usually is one of the most important ones that we need to know. So in calculating that, this is opposite of that, so we're going to be using sine. So it's going to be 15 times sine of 70 degrees will equal the vertical velocity. So, okay, and that equals 14.095 meters per second, which is, 14 meters per second if we go to two significant figures. So the velocity at the peak is going to be 0. So Vf equals 0. The initial velocity, which is the vertical velocity, I'm going to leave in at 14.09 for doing the calculation. The acceleration is minus 9.8 meters per second. T is what we're interested in finding out. D we don't need to know. So the first thing we do is we look at the equations and we're looking for one which doesn't have D in. These are the kinematic equations. And that is Vf equals Vi plus A2, so similar to the previous one. And that's at 0 equals 14.09 minus 9.8 times T. So that equals 14.09 equals 9.8T. So 14.09 over 9.8 equals T. So divided by 9.8. And that is, if we just move that up, I'll get rid of some of this. That's going to be 1.4383 seconds. Or if we just do to three significant figures, maybe 1.44 seconds. Okay, so that's your answer there for that one. Now, what is the size and direction of velocity at the highest point? Okay, so this is similar to the previous question again. So if she's going at 5.1 meters per second at the highest point, it's going to still be that velocity. The size is equals 5.1 meters per second. Now the direction we'll just say is to the right. Because there is no force acting, so once again we're in the same way of explaining it. There is no force acting on the horizontal velocity. Okay, so if we carry on with that, because we ignore air resistance, so the velocity remains unchanged. So it's pretty much the same answer. So that's a question that does come up a little bit, okay?